So to start this unit, I'm going to have you go ahead and pause the video and just work on this warm-up just to practice writing each fraction in lowest terms. Let's start with number 1. 14 and 16 are both even, so they can both be divided by 2, which gives us 7/8. 24 and 64 are both divisible by 8. Now you might not have realized that 8 goes into both of them, and that's okay. Remember, you just keep dividing until you can't take anything out. So 24 divided by 8 is 3, 64 divided by 8 is 8. 9 and 72 are both divisible by 9, so you end up with 1/8. And then 45 and 120 are both divisible by 15. So 45 divided by 15 is 8, and 120 divided by 45 divided by 15 is 3, and 120 divided by 15 is 8. Now the focus of today's lesson is to learn to find equivalent ratios and to create proportions. A ratio is a comparison of two quantities by division. Below you'll see two rectangles. In one rectangle, the ratio of shaded squares to unshaded squares is 7 to 5. That would be this one right here, because we see 7 shaded squares to 5 unshaded squares. In the other rectangle, the ratio is 28 to 20, shaded squares to unshaded squares. However, both rectangles have equivalent shaded areas. So ratios that make the same comparison are equivalent ratios, or kind of like looking like equivalent fractions. Because if you look here, if we look at the shaded regions, even though the pieces are cut smaller in that second one, as a picture, they are the same. Keep in mind that ratios can be written in several ways. We could write them as 7 to 5 with the 2 written out. We could write it with a colon in between, and we can also write them as a fraction. And they all name the same thing. Now let's put into practice what this actually means. We're going to find two ratios that are equivalent to each given ratio. So on this first one, we have 9/27. So we want to give any ratios that are equivalent to those. Well, one way we could do that is just simply multiplying each of these by 2. 9 times 2 would be 18, and 27 times 2 is going to give us 54. We can also reduce or simplify just like we would a fraction. So here, since 27 and 9 are both divisible by 9, this would be equivalent to 1/3. So why don't you go ahead and pause the video and try the next one on your own. So 64 to 24, we could start by multiplying each by 2. So 64 times 2 is going to give us 128. 24 times 2 is going to give us 48. Here we could also divide each by 2, or we could also divide them by 8, which is going to give us 8/3. Now one thing with ratios that you want to keep in mind is we're not going to change them into mixed numbers because they're not actually fractions. We're comparing two parts through division, so we'd leave them as an improper fraction. Ratios that are equivalent are said to be proportional or in proportion. Equivalent ratios are identical when they are written in simplest form. So let's look at what that actually means. So here we're going to simplify to tell whether the ratios form a proportion. So 3 and 27 are both divisible by 3, which gives us 1/9. 2 and 18 are also both divisible by 2, which is going to give us 1/9. Since both fractions simplify to 1/9, they are proportional. So let's try another one. So here we have 12/15 and 27 over 36. So 12 and 15 are both divisible by 3, which gives us 4/5. 27 and 36 are also both divisible by 3, but also 9. So I'm going to divide each by 9. And this is going to give us 3/4. Since 4/5 is not equal to 3/4, these are not proportional. Alright, so now it's your turn. Go ahead and try these two out by simplifying the proportions. So 3 and 15 are both divisible by 3, which gives us 1/5. 9 and 45 are both divisible by 9, which also gives us 1/5. So these are in fact proportional. 14 and 49 are both divisible by 7, which gives us 2/7. 16 and 36 are both divisible by 4, which gives us 4/9. Since these two are not equal, they are not proportional. Alright, so at 4 degrees Celsius, 4 cubic feet of silver has the same mass as 42 cubic feet of water. So at 4 degrees Celsius, would 210 cubic feet of water have the same mass as 20 feet of cubic silver? So here we can see that there's a proportion set up, and we set up the proportion as cubic feet of silver to cubic feet of water. 4 and 42 are both even, so this would simplify to 2 over 21. 20 over 210 are both divisible by 10. So this would also simplify to 2 over 21. So yes, they would have the same mass as 20 feet of cubic silver. Alright, so now it's your turn. Go ahead and set up the proportions and see if these would be the same. So 2 cubic feet of water has the same mass as 21 cubic feet, or 2 cubic feet of silver has the same mass as 21 cubic feet of water. So they're asking, would 10 cubic feet of silver have the same same mass as 105 cubic feet of water? Now 2 over 21 can't be reduced, but if we divide each of these by 5, this becomes 2 over 21. And since these two are equal, yes, they would have the same mass. Now let's look at one more example. Why don't you pause the video, read through this problem on your own, and see what you get for an answer. So Kate poured 8 ounces of juice from a 64-ounce bottle. Brian poured 16 ounces of juice from a 128-ounce bottle. We want to know what is the ratio of juice that is missing from each bottle, and are those ratios proportional? So since it's talking about juice that is missing, here we have 64 ounces. If we took the 8 ounces out, we have 56 ounces left. And we want to know, is that proportional to having a 128-ounce bottle with 16 ounces missing, which is going to give us 112 ounces. So now we need to reduce both. So 56 and 64 are both divisible by 8, which gives us 7/8. 112 and 128 are both divisible by 8, which gives us, let's see, we have 16 and 112 divided by 8 is 14. Those are both divisible by 2, which also gives us 7/8. So yes, the ratios are proportional.